So this talk is going to be about Near, and we are a blockchain company, and we want to decentralize the web again. So first, let's start with intro, and I'm Evgeny. I'm currently at Near Protocol, and before I was doing some VR and 360 video at Facebook for a few years, and before I was working on a backend at Google, and I also have a gold medal at ICM ICPC competition, and this kind of programming competition. So why do we need decentralization in the first place? And here's the problem. Let's say a person was driving for Uber and got 100 rides and pretty good reputation on Uber, but then something happened with Uber. Maybe they dropped the prices, or they dropped the how much they pay in them, and the person wanted to go work for Lyft. And for them, they cannot go there because they are locked into the data that is logged by Uber, and they will start from the beginning. So if data would be open, then they can easily earn reputation both on Uber and Lyft while only driving for one of them. And if they can share this reputation in a trusted manner where both parties can trust how the reputation is acquired, then they can build a shared reputation. So this kind of benefit that can bring a decentralized platform where all data can be shared up to a certain point. So a little bit about Near Protocol. And so this is a scalable blockchain. We have sharded state, sharded processing. We're using thresholded proof of stake. I'm not going to go into this custom consensus. And we run smart contracts with WebAssembly. So to simplify this, in my opinion, we are the best decentralized computing platform. We love developers and we love users, and we fully open sourced on GitHub. So what does it mean? So by default, if you're familiar with blockchain and development, most smart contracts are kind of complicated. In our sense, we use WebAssembly as our core VM, and on top we have a wrapper in AssemblyScript, which you just heard it talk. So we also have an in-browser ID where you can just jump on it, and we support tools through NPM. So it's pretty familiar for everybody who did some JavaScript development. We use simple JSON for passing data around, and I'll get into this. This is actually pretty cool because, as you saw before, WebAssembly is about numbers. You can also run tests and interact with other apps using some common API. So this is our studio. It looks like WebAssembly Studio. So we just forked it, put our logo on it, and it now works. We also love users. And if you ever try to use decentralized apps or just do a transfer, you know how complicated it is to set up, acquire tokens, and do all this stuff. And at the end, you need to understand what is transaction, this 64 bits for hashes and stuff like this. So what we do differently is we're trying to simplify it from a user perspective as well. And for that, we're trying to make the experience of using decentralized web, or at least the blockchain and the backend, as simple as using a Facebook as a login. So we have a web-based wallet where you don't need any plugins. It's easy account creation, and it's also allow automatic approvals for simple transactions that doesn't involve any monetary transfer. And we have a place to discover new apps. So here's an example of how the experience looks. This is one of our templates which shows how to integrate. So when you click sign in, you land at the wallet, which asks you to create a new account. You create an account. Then you get a pop-up flow, which is similar to Facebook. Hey, the app gonna do this, can do this, and cannot do that. And then you can just interact with this. Never need to approve this again until you go to some monetary transactions. So this is what we want to experience to look like for like decentralized applications instead of actually like going through like MetaMask and stuff like this. So this was an intro about Near protocol, and let's actually jump about WebAssembly. So from outside, WebAssembly is super cool, and everybody's like super hyped about this. Inside, it's just a kind of assembly code, so it's not as fun. But I want to talk why we actually choose WebAssembly. So there's 5 points. So this virtual machine with all the benefits of VM, and if you run blockchain application, you want to be able to, like you run application on a blockchain, you need to be able to isolate the code. It also has to be fast because it's not run by a single entity, but it actually run by like multiple people who need to come up with a consensus. And to come up with a consensus, the execution on different platforms has to be deterministic. Also, WebAssembly compiles from many languages, as you saw before, and it has a growing community of developers, which is awesome. So about the virtual machine. So WebAssembly gives you some guarantees. It's sandboxed, safe. It has limited memory, limited stack, limited external APIs that you can provide into the WebAssembly. It's also platform independent. And you can, with some tricks, you can do limited execution. So you can limit how long your app runs. And on different platforms, it's going to execute the same way. So about the VM performance, we started with Wasm because we just started with one of the repo that was using. Wasm is an interpreter, and we using Rust and Near protocol. So there's a link you can probably like look it up at standalone WebAssembly VM benchmark. And for us, the choice was we needed a Rust VM because we wanted to integrate it closely and we need to have a good control. So there was 2 choices for us. It was Wasm and Wasmer. And Wasmer is actually about 50 times faster on this benchmark. So this is pretty good, and we decided to try it. From our own benchmarks, once we switched, we got about 10 million operations from around 250 milliseconds to 14 milliseconds, which is more than enough. And it got us around like 18.5 times faster on our side. So we love Wasmer. Thank you, guys. So about deterministic execution. So Wasm spec actually has some, so first of all, there's 4 types. So there's 2 integers, 2 float types, and they have some non-deterministic behavior for not a number. So not a number, essentially what's non-deterministic about this is when you get a not a number, some bytes or some bits of this number are not determined on what it should be on different platforms. So for us, running a consensus, you can try to have an application that will try to use not a number, then copy bits out and put it into output. So if 2 different platforms runs this and get a different results, we have a problem. So, well, if you don't have floats, you can get a none. So we basically just truncated floats using some hack that we do for measure overall execution. And for most of the decentralized application, floats can easily be simulated. And you don't really need to do any of this complicated stuff. So next, the language support. There's actually a page on GitHub which links all the languages. And you can go there and look up for the support. They have icons, meaning like how mature the language is. And we picked AssemblyScript because it was easy to go from a traditional TypeScript to JavaScript development. It has classes and generic templates. It produces small Wasm binaries. So we also support Rust, but AssemblyScript is our prime target. It's an active development by 2+ people. And We also implemented the JSON serialization on top, so you can actually go and move data in from the browser using a JSON towards the AssemblyScript and lands on Wasm on a blockchain and go back. So the development process is actually pretty good with this. And the 5 is like Epic developer, so look around. So this is people who actually defined the beginning of WebAssembly, and it's going to grow from there. So we have a Reddit subreddit where we're trying to showcase a cool application built on us. Currently, we're running DevNet. We're in the move to next step, which is multi-node, AlphaNet. But we already have a bunch of applications built. And here's one of the examples. So we built a Near place. We have a website built with Near, where there's like 2 applications right now. That's kind of our like prime showcase applications. So this is similar to Reddit place, except not really blocked by waiting 1 hour to change a pixel, because we don't have so many users to actually get to this stage. But I'll showcase this later. We built a memgen because we have a lot of Googlers internally, so we need a way to communicate. There was a company on our hackathon, Pinky Promise, so you can create a Pinky Promise on a blockchain and it stays there forever, and you cannot like say, okay, I didn't do this. We built chess. So chess is an interesting use case because most of the stuff happens on the front end. Even so, ideally you would have validation on the back end, and you can just play and connect. So this is actually hosted on GitHub pages, and it doesn't need any backend because everything is doing through a blockchain backend. And today we had a hackathon in the office, and stuff that I wanted to build for quite some time is kind of cross-contract game. So we call it Meta Near, and it's very early stage. An idea here, you have an open world where you can claim cells and you can deploy contracts and URLs there. So when you land on the page and URL below, it will show you the page, and you can interact with this in a decentralized fashion. So thank you for listening, and here's a few links. So we have a Near chat. Our IDs can be go from near.dev, and our website is Near Protocol. And I guess I have about half an hour to actually do the demo. So I'll invite one of my colleagues on stage, and we'll do some live demo. Oh, this works. Try this.
All right, this one works? Got it. Okay, cool. So we actually changed the format in our demo so there's 2 people, so that when we're actually writing the code, one person can explain what's happening instead of just like long 2-minute to 5-minute blocks of silence. So my name's Peter. You can find me on Twitter at PotatoDePaulo. That's D-E-P-A-U-L-O, Potato DePaulo. Follow me on Twitter. But what we want to show you guys is the Near Studio. So it looks a lot like the Wasm Studio because it is a fork of it. It's not just a simple fork, though. We did a lot of stuff behind the scenes. So what this actually does is you can write a fully functioning smart contract and a front end. You hit run, and it gets deployed out onto this big platform we built behind the scenes, which uses GitHub Pages and a lot of services to make it work. So technically, this is running like on our DevNet right now. So this is one of the templates. This is a guest book. You can log in with Near. As you can see, it's got our wallet. The wallet's really cool because I don't know if you could. So actually, just really quick, who here is like familiar with the blockchain space, cryptocurrency, anything at all? Let's do a level of interest and/or having run into it is how high your hand is. So like super into it is really high, a little bit. Okay, awesome. Yeah, great. So. If you're coming from Ethereum, which is like the main player right now, the wallet that is used is built by this guy Dan Finley, and it's called MetaMask, which runs in a Chrome extension. This doesn't seem like a big deal if you're from Web 2.0, but if you understand how blockchain works, there's a lot of stuff that has to happen for the wallet to work. So what we're really trying to do is every single step of the way for developing blockchain applications, and then for developers to actually deploy applications to their end users, we want to have a seamless experience. We want it to be really good. Anyone who's built on Ethereum will tell you that right now, Solidity, it's not great. It's kind of tough to use. So that's kind of the substrate context for you guys of why we're doing this and like what specifically we're doing. Another one of the cool things is when you call contract.getMessages, that's actually looking at the contract you wrote that's in AssemblyScript, compiled to Wasm, and then pulled into our front end through an API. Right? So that's the SDK.
So yeah, let me explain. So this is a function that I just called getMessages, and it's kind of old API, and what I want to start today because we don't have a lot of time, but I'll go and modify it to a new API to showcase where we actually got, and it's going to be simple to understand. So what it does, it returns an array of posted messages. Posted message is a type that you can export. And what you get on a JavaScript side is actually, if you just do this with a wait, so you get an array of JSON objects that frontend just deserialize, and it's much simpler to work with comparing to like you have to parse some binary stuff.
So one thing I wanted to do, and this is going to stress test Eugene a little bit, is get a suggestion from the audience for a blockchain application that we're going to live code. So does anybody have an idea for like something that you thought of that would be like kind of cool for a blockchain application? Even if it's complicated, we can walk it back to like something we can do in 20 minutes. Any idea at all? One of the ones we did last time. Yeah, what's up? Pokedex? Okay, so walk me through the functionality. Like, what would you expect? Okay, so you got to store Pokemon. Got to be able to look at them. Okay, so each Pokemon is, I guess, would be unique, right? So, you know, functionally, it would just be like a list where you can add items to it, and then you can read those items out, right? So Pokemon would have a name. All right, so why don't we start with the model?
Sure.
Do you want to do that?
Yeah, so
all right, let's do it.
just...
Does that sound good, Eugene? Do you want more of the spec? So
no,
Pokedex?
let's start. So
let's do it.
We'll do Pokemon object. So it might need an ID, but we'll use a unique index probably, and I'll have a name and an image.
All right, going hard mode on this one.
All right. What else we need?
Yeah, what else? What do we need information about the Pokemon? Ooh, attack power.
Attack power. Oh. Oh yeah, sure.
Is that better? Can you guys see in the back there? Okay, cool. All right, I think that's probably good to start with our Pokemon. So now we're gonna have to store these in some way, right?
Yeah. So we'll nuke this code. So what I did, I added a new API which allows us to do some cool stuff. So we added persistent collections. So I'll need to talk a little bit how a smart contract run before we can go into details. So every time you call a function on a blockchain, so something like get messages, it actually pops a new instance of this compiled code that has completely blank memory, but it can call backend, or runtime on a blockchain to read key value store. So behind the scene, it's kind of like bytes to bytes mapping that you can read, but you always start from an empty memory. So what we added is persistent collections. So you can say Pokemons, for example, collections vector, where you can store Pokemon. And it needs to have a prefix, so let's say Pok. So we'll need two functions. One of them is add Pokemon. And this function is basically just going to take, for example, a Pokemon. And do not return anything. So it's going to be super simple. It's just going to do Pokemon, Pokemon's push, and you just add Pokemon. So no serialization needed here because behind the scenes it does all the stuff where it serializes this, find the next index where to put it, and gets it there. So it actually returns you an index, so you can use it. And we also have a logging ability, so you can log data that is executed on a blockchain, and this is how you debug it. So you can say,
and that'll show up in the console, in your browser, not just down here.
Pokemon, and for example, Pokemon to string. So this add function. So to include it, we actually need to modify our main TS. So this is about guestbook right now, which a lot of stuff that we probably wouldn't need, but we can reuse. So I'll do add Pokemon, and I don't have. I'll just add get Pokemon and num Pokemons. So we'll need to query how many Pokemons we have and stuff like this. So if I click run, well, it fails. This compilation error. I guess I need to cast index to string as well. All right. Okay, so why am I not logged in?
Oh, there's probably an error in the front account.
And you fork. So every time you do development and you don't own it, it will create a new fork. And why I cannot log in? It's because get messages is unknown. Well, sure. So let me just create.
Right. So again, this was forked from one of our templates. So if you go to near.dev, that'll open up our studio. And inside of there, you have several to choose from. So all of that code that you saw earlier, we're going to be basically deleting it to make way for this Pokemon stuff. But yeah, so he's got to uncomment out get messages. Because just so you guys know, the guestbook has a loop. We don't have events yet. So you have to pull the chain to get messages. Kind of like old-fashioned Web 2.
So I already had an account, so it just allows me to sign up with my account. So now I have contract, and I have class get Pokemon. So to add a Pokemon, I need to pass a JSON, and not an empty JSON. I also need to pass parameter to a function, which is going to be a Pokemon, which is going to take its own JSON, which is going to represent a Pokemon. And our Pokemon has attack power, so let's say attack power 42. It's going to be name. It's going to be Pikachu, of course. And, okay.
There you go.
And I don't have an image because I didn't. Anyway, we'll add a Pikachu 2 with an image. So I'll use memgen, our memgen, to actually find an image for me. All right. And that's going to be my URL. All right. So we added a Pikachu. This Pokemon Pikachu 2 number 1, and it has all the fields. So I need to add a few more functions for this to work. So let's do num Pokemons. And it's gonna return Pokemon Slam. So if I deploy it, I, in theory, can call non-Pokemons.
So and one side note I want to point out is, so I come from a pretty heavy JavaScript background, a lot of Java too, and so one thing that this is really reminiscent of is just like developing a regular application, right? Which is what we're kind of trying to get at. This studio is great to use. It's pretty fun, but there's also like the local way of doing this, which is pretty much the same process, except that rather than running in Studio, you're running through Terminal and whatever your favorite text editor is. Yeah, so if you want to build blockchain apps, I think we built the best way to do it.
So interesting is what people usually get confused with this is you cannot just pass an argument like this. It's going to fail because it takes a positional arguments, and this is much deeper in the way how WebAssembly works in general. So you can pass now an index, and it's saying assert failed. So which is, I assume, it should give us assert and like what actually failed. A log message, maybe it doesn't, but the index didn't exist, so we just didn't have this Pokemon. So maybe something is broken for us, but here's the Pokemon if you get something that's available. So now we're done with the backend part for now, so with the contract part. We basically just need to be able to render Pokemons. And for this, I'll just reuse get messages that we used before without much modification. Actually, we don't have get messages. We have get Pokemon, so I'll do num Pokemons and update Pokemons. So idea here, what we need to do is
so I don't know if you guys caught that, but we're basically done with the back end of this, right? So the main.ts is in assembly folder is where your entire smart contract goes. You can also write, it doesn't have to be main.ts. You can write multiple different TS files and then import them, just like we did with the model. I think it was called model.ts into that one file. So the cool thing about that is pretty much like you're going to spend more time writing your front-end application than you are actually sitting down and writing blockchain code. And again, like that doesn't maybe sound that cool in a group of people who are doing mainly like Web 2.0 applications. But like try to do it in Solidity. Try to do it on Ethereum. It's very unpleasant. I've written a lot of Ethereum smart contracts, and like it's not quick, and it's yeah. So I would urge you guys to try like some whatever blockchain buzzword stuff that you've heard before. Like yeah, give it a shot over here. See if you can come up with some cool stuff.
All right. So what I'm doing here is once I get a number of Pokemons, I'll just, for every new Pokemon that I haven't seen before, I'll call a promise to get this Pokemon and to try to render it. And I'll just remember the number again. And I'm also going to only do this for the last 10 Pokemons to avoid render all the Pokemons first. I guess I'll just reuse some of this stuff. So messages. Pen. And I'll do something simple.
While Eugene's doing that, I am curious though. Are all of you developers? Is everybody here? I didn't even start with that. Let's do the same, like how technical you are is how high your hand is. Technicality? Okay, cool. Except for you guys, saw you, Wasm. You guys like, no. Liars. Yeah. Cool. What kind of applications do you guys generally build, like in your free time? Are there any specific projects that you guys are working on? That is a weird time to ask this, but. All right. Game emulators? Anything else?
All right. Okay, that kind of works. You kind of get a JSON, it's just not a nice Pokemon. So I'll just replace to something like render Pokemon. And Or maybe I'll use title. That's going to be epic. Okay. Can I append multiple? Oh, I can do array. And I need to return this.
Oh yeah, I also forgot. On Built with Near, within probably by tomorrow, there's an example with React and Next.js that we'll post up. So this is in jQuery, but yeah, if you want to see kind of like other integrations, the to-do MVC is in Vue, and then React Next.js is getting posted tomorrow. Yeah, so another one of my awkward interludes for you guys.
All right. Let's see if anything about this works. All right.
Yeah.
We got some Pikachu.
Way to go.
All right.
Awesome. So like this is a pretty good basic implementation of Pokedex, right? And I think it's pretty awesome. I mean, I think a huge part of that is Eugene. Can we get another round for Eugene? Just because.
All right.
Yeah, he's an awesome programmer. But it also demonstrates just like how really easy this stuff is to use. And I think, do we have time for questions?
Yeah, we have time for questions. I also want to show a few apps that I mentioned. So this is a near place. And you basically can draw here, and it updates it. And when you reload, it pretty much gets it loaded. And we store it like a block, so it's not like a single call that renders entire thing, but kind of cells that like periodically gets updated if someone else is drawing here, let's say, and you have a color picker on the bottom. This is the meter near thing that we actually did today as part of the hackathon. And so when you land, you have a iframe on the bottom, and this iframe is you'll have to authorize this as well. So this is one of our guest books. The idea behind this is not only like you can showcase different URLs, you can also do integration with the contract that in the cell. So for example,
show what the grid does. So that circle is the player. We made this in like, I don't know, like 4 hours, 2 hours, 2 or 4 hours?
Yeah.
And this grid represents like a map you can travel on. So like all of the white squares are unexplored land, sort of like in Minecraft to be like past where blocks are rendered. You can travel 7 squares, I believe, in any direction. Red squares are things that other people have already claimed for themselves by putting a link down there. So you want to click on one of those red squares?
Yeah, I'm trying to get there. I'm not
sure
sure
trying to get over there? Trying to get close enough?
Maybe it was too far.
And then, yes. So this is like user-generated content where, I mean, all the users were people in our office. But you can click around any of these squares. And then we don't have a UI for it yet, but you can deploy actually URLs from the console that the other people can then discover. And yeah, we're probably going to add more stuff to this, but this is the example that this is using React and Next.js for rendering and compilation, respectively. Oh yeah, so that's how you deploy a link. Is that the Pikachu image?
Yeah, that's a Pikachu. So if I go back, it's now a red cell. And
yeah. One thing Jane, one of the developers who also played with this, is trying to do is fork this entire application and then put it inside of one of the cells so that you can then go deeper into the near-verse.
So this is some external stuff that you can put. I'm trying to find if there's a link that's memgen that showed items on. No. Anyway, so there was a page that integrates with this contract to basically display items that you acquired while walking there. So some contracts can actually, when you land on a cell, it can give you some item that in theory you can design all kinds of rules there, which we don't currently have, but any user can modify cells They can claim ownership. They can later trail cells there, and they can also like prevent you from going there by blocking the path with something like, oh, you need a red key or something.
Awesome. Yeah. Do you have any other demos, or you want to take questions?
Yeah, we can do questions.
Cool. Yeah. What do you guys got? Any questions? Sure.
Where are the blocks stored?
Eugene.
So right now, blocks store on our DevNet, and we have like a debugger. I don't know if it's gonna work. Probably I can try to.
And in the future, blocks will be stored across nodes, right? So the way a blockchain works is each person who's in the network would be running, in the case of Ethereum, like the full network on their computer with cryptographically signed nodes that are in a Merkle tree, right? So in our future, though, you'll be within a shard. You'll be running your entire shard on your node, basically. Blocks would be stored on your machine and everyone in your shard's machine. Yeah, so actually anyone can run a node on our AlphaNet now. So this is DevNet, so we're running all of this stuff. AlphaNet is launched, and you can go to our docs. I forget the URL, but if you go to nearprotocol.com, you can check out, docs.nearprotocol.com. I should know that.
Long day.
Yeah, it's been a really long day. So I wrote most of the documentation, so I should really know the URL. But yeah, if you go there, you can check out how to run an AlphaNet node, and you can start playing with this on kind of a more robust ish version.
Yep.
My question is about the Near Studio.
Mm-hmm.
Could we add some extensions or leave it?
What do you mean by that? Oh, yeah, sure. So you're asking, could we add code snippets to the studio?
And extensions.
Code snippets and extensions. Yeah, absolutely. I mean, it's open source. So if you put in a PR, then... Oh, like as if, like an IDE, like packages. Not yet, but that's actually a really cool feature. So maybe soon I'll put an issue down as a feature request. And then as far as like adding code, though, you can download and upload back up to this just like any other IDE. But yeah, that's a good idea.
But we also support like non-IDE environment where you just download stuff and you can just in console like do npm install, npm build, and like later npm deploy. This is what we're trying to get to, which is most familiar for people.
Yeah.
How does the serializing of the arguments and the return values work? Is there pre-processing done on the TypeScript?
Yeah, so this is what we do. So this is our compiled version of a model. So if you can see, original model has like one class. So this compiled version, it pretty much has a wrapper function that wraps, yeah.
And that question for the people at home was, how does the serializer work?
Yeah, so in serializer, we use a JSON encoder, decoder. As far as, so we basically generate, like TypeScript doesn't, AssemblyScript doesn't currently support very well in-depth exploration of type. Otherwise, you can just like, if you had access to this at the runtime level, so you will be able to just one by one go through every argument and every method and just serialize this manually. As when you call functions, we actually have to do some work. We wrap every function with our kind of wrapper that at the end just reads like single index of where the buffer is, and then it parses this JSON into arguments.
Any other questions? Oh, yeah.
What is the economy of running a shard on this decentralized network? I mean, I know Ethereum you kind of pay in gas. Is that going to happen with Near?
Yep. Okay, so the question was, what is the economy in Ethereum you pay with gas? We're going to have some concept of gas because, blockchain doesn't work without gas. But we're not using proof of work. We're using proof of stake, which is Ethereum 2.0 is moving towards. So without getting too into like the economics of blockchain just in general. The way it works is you have a certain number of coins that you either bought or you were given, and then you put them as stake, kind of like saying, I'm going to put these down. And it's sort of like seeding versus leeching in peer-to-peer programs, right? Like, so imagine like you got a faster download speed if you seeded more stuff. Hopefully that metaphor was not like just more convoluted. Giving away how I get my media. Sorry. Yeah, go ahead.
So the follow-up to that is, like, in this like traditional hosting, is there like some savings to be gained by using Wasm, or is like is Wasm anything that we can use in your platform versus other web technologies?
What do you mean by savings? So the question was, is there some savings to be gained by using Wasm on the blockchain?
Processing power or amount of data?
Yeah, well, by itself, like when we switched to just one Wasmer interpreter to Wasmer, we got a huge boost in performance because suddenly we can do much larger number of transactions per second on the same hardware. So this was one boost that we got because like Telmus runs natively.
It's also kind of what Aaron was saying, which is you have predictability of performance, which is actually something that's really important for blockchain, because gas is actually paying for computation, right? So if you can get closer to predictable computation, then you can get closer to predictable gas. So if you're a developer and you're saying, oh, I want to build some big thing, and it's going to cost me or my users some amount in gas, that'll give you a little bit of a stabilizing force, which is what we're moving towards. Yeah. Any other questions? Okay, I think that's it then.
Cool.
Yeah, you guys can come talk to us. Oh, we have T-shirts also. So me, him, or Pratik, I don't know if you saw him. Come ask for shirts if you want them or bug us. All right, thanks everybody.
All right.